Hello everyone. Welcome to the 6F. Some people ask me why they're gonna skip the D and E because I'm gonna try to graphing the transformation straight away with sine and cosine graph. Um, Today I'm gonna teach you guys how to do by hand and how to do by CAS calculator as well. So we're going to consider the translation graph and function the form with a sine nt and g equal to like a cosine nt. Um, so we're going to try to graphing with those two first. Um, so first thing first, we're going to try to understanding about uh, how to using the calculator to calculate this how to say the range and the domain first. So we know if you want to graphing some like a cosine graph or sine graph, you need to find your period. So what's the periods for those two? And also we're gonna find out amplitude, which is your positive maximum position. Um, so first thing first, we need to know our period. So how to calculate the periods? So we need to know if you want to calculate this A equal to A sine nt, so that means your graph looks like the periods will be equal to 2 pi over n. And if you have y equal to a cosine nt, your periods equal to 2 pi over n as well. And so we can see these ones amplitude as well. So the amplitude gonna be the front number, so as we know. So and depends on which number you're gonna be in front, and they're gonna help you with that. So clearly we can see the question A, the range will equal to -3 to 3. So that will be the lowest number and highest number, minimum and maximum. And also your periods will be different a little bit. So remember you had 2 in front of t. So we could do is equal to 2 pi over 2. So equal to pi. So that's your period. Okay. Period means like you start from beginning points and back to the beginning points, like the same, same y values. Okay, so we're gonna try to using the calculator to calculate this. So how are we gonna use the calculator to calculate? So first thing first, I want you guys to remember. So if you want to calculate and to graphing the sine graph, we could do a quick exception, which is we can do a quick running by hand, which is like that. So hopefully you guys understand what's going on. So we're gonna start with, because your t value is from pi on 4, so we can say you start from pi on 4, and we do half pi, and we do 3 pi on 4, and we do pi, and 5 pi on 4. Okay. So, and sorry about that. We're going to keep going with that. So that will be 3 and -3. So you start from pi on 4, you're going to 2 pi on 2, sorry, pi on 2. So you're going to get the highest points. That's the maximum. And come back and get minimum. And here is the basically how to do by hand. I think this double check with pi on 2. Yeah, let me try. Yeah, it's gonna be 3 and it's gonna be 3.2. Yeah, good. And there's nothing much about it. You can substitution these kind of numbers and you will find your answer. Or we could do just doing a quick CAS calculator thing. So we could do 3 times sine, and we can move this one into the 2 pi 2x 2 times x minus control divide, so pi on 2. So we could do pi and wait, what happened to my pi on 2, and make sure you will have your range, sorry, domain, so which is from pi on 4. So we can say, so control divide, so we say pi on 4 less than equal to, less than equal to x and less than equal to 5 pi on 4. So 5 pi on 4 and enter. So that will be your graph from from the CAS calculator. Yeah. So another thing we could try with our function is, let's try if I move this. Okay, if I move the 2 outside, does that gonna help? There's nothing. So make sure you have to submit your 3 or 2 or whatever number in front of the bracket into the bracket. Okay? Alright, let's back on here. So the B, I want you guys to try to using the CAS calculator as well and to find out your questions and answers, please. And here is the observations about the examples. So if you find something like that, here's the transformation for question A. So it's translate like pi on 4 to the positive direction of the t-axis, because it starts with 2t, it'll become to 2t minus pi on 4. And if you have 3t cos, and they're gonna be going to the left, so which is negative on the t-axis. And you can use the transformation part if you want to using sine t and become to y equal to 3 sine 2t minus pi on 4. So we're gonna rearrange the equations, which is we can divide by 3 on the both sides, and that become to pi, y on 3. It's your actually dilate factors 3 from, so x-axis, or we say t-axis, okay? And also dilate a half, okay, in the y-axis, because if you're using t, so that become to t, so the both sides are divided by a t, so divided by 2, so that become to t over 2, so okay. And that means a half. And then translations about the pi on 4 units are going to the positive direction, because you plus in your transformation. So hopefully that can give you a quick ideas. Okay. So now what we're going to do is we're going to graphing this by hand. So the first thing first, we're gonna try to do to find f0 equal to sine negative pi on 3. So if you find the sine negative pi on 3, so that equal to the negative this fourth quadrant, so that equal to negative root 3 on 2. And if you have 2 pi, so that means sine 2 pi minus pi on 3 also equal to negative root 3 on 2 because it's on the fourth quadrant. If you remember the unit circle, that'll be on here. Okay, so perfect. And then we're gonna sketch in the graph. Let's see the translation part first. The first thing first, if I start from y equal to sine x, that's the start at the beginning, you actually y equal to sine x minus pi on 3 actually translated pi on 3 units to the right. And we have to find the period is 2 pi, and amplitude, very important thing, always gonna be positive, is 1. Okay, is 1. Alright, if you write this, you're done the pretty much like 1 mark. Now what we're gonna do, we're gonna figure out the and then we know the 2 points already, right? So when 0, negative root 3 on 2, and 2 pi is negative root 3 on 2. Okay? Because that's your starting point, which is your domain range. So what we do is in here, we're gonna graph a quick Cartesian plane. Oh my god, sorry, Cartesian plane. Yeah, perfect. Start point is 0, so when a0 is negative root 3 on 2. So that's your starting point. And also we have, because we move the whole thing, so if I graphing my origin one, y equal to sine x, you always start from 0, right? So that's pi on 2, that's pi, and that's 2 pi, sorry, that's 3 pi on 2, and that's 2 pi. Okay, so your graph will be looks like that. So negative 2, so your graph will be looks like that. Let me try with a quick question. So I'll be like that, and going down, and going to the negative 1, and going to 2 pi. So that's the origin sine x. But now, because you shape the whole thing to the right hand side by, how to say, by how many units? By pi on 3 units. So your graph become 2. You start from pi on 3 is your starting point. Pi on 3 is starting point. And so because you shape the 2, so you plus pi, so pi on 2 plus 3 pi, sorry, plus pi on 3, which is like 5 pi on 6. So 5 pi on 6 is gonna be the next one. And also you're gonna go with 4 pi on 3, so which is So in here, so 5 pi on 3. So 4 pi on 3. And then the next one will be 11 pi on 6. So that's the basically and next one will be here, so will be 7 pi on 3. So your graph will be looks like start from 3 pi on 3, up to you're going up to 1, and you're hitting the 0, you're hitting to the -1, and you're going up to here. So that's the graph you're being shaped. But we're not gonna go to that further. So which means we don't need here until you hit to the 2 pi. And also you have something. So we're gonna keep going that way. And that become to the final graph. And that's the graph is y equal to sine x minus pi on 3 from 0 to 2 pi. Yeah, I know the graph that doesn't look perfect, and that should be the curve, and then I try to fix it out later. So I'll be like that. I'll be like smooth curve, and something like that. Okay. Hopefully that makes sense. And this is start beginning the transformation part with sine and cosine graph. So next lesson, we're gonna try to do the sketching the graph with a little bit trickier. Okay, I'll see you guys next time.